Hi, everybody, and welcome to DataBytes, the lunchtime webinar series sponsored by the National Consortium for Data Science. Today's speaker is Mac Devine, and he is Vice President and CTO of Emerging Technology and Advanced Innovation in the IBM Cloud Division. During his time at IBM, Mac has been a master inventor, an IBM Distinguished Engineer, a member of the IBM Academy of Technology, and an IBM Fellow. He has served as the Chief Architect for System Z Enterprise Software, as the CTO for IBM Cloud Partnerships and Client Innovations within IBM Corporate Strategy Team, as Director and CTO for Cloud Portfolio within IBM Global Technical Services, and as Vice President and CTO for Cloud Networking Services and Innovation. He's also the co-author of Springer's Handbook of Cloud Computing, which is regularly used in college and university courses, and he is a faculty member for the Cloud Expo, Things Expo, and the IoT LinkedIn community. Mac's talk is titled SurThrival, A Guide to the Perfect Digital Storm, and he's going to talk about how we can ride the tidal wave of big data, cloud, and IoT technology by embracing things like microservices, continuous delivery and operations, and composable services. As usual, the talk will last about 30 to 45 minutes, and we'll leave some time for questions at the end. If you have questions, we ask that you write them down in the chat box and send them, and we will read them back to the speaker after he's done with his presentation. So without further ado, again, welcome, and welcome, Mac. I turn it over to you.
All right, thank you very much. I appreciate the opportunity to talk today. When I talk about a SurThrival guide, I'm like, what in the world is that? So really, what people I see that are doing today, people I mean in terms of enterprise customers, service providers, vendors, is they're just trying to survive. They're trying to survive the onslaught of data. They're trying to survive the increased requirements in terms of the speed at which you have to deliver services. And what they really want to do is they want to thrive. They want to thrive in this cognitive world that we live in, and they don't know how to do that. And what I want to focus on is, well, you know, what's the guide to move from that survival state to that thrive state? The most important chart that I have here is the very first one because it has my contact information, my email. You can also contact me on Twitter. Anything's fair game. So let's go ahead and get started. So this aspect of an always connected enterprise, we live in a connected world. When IBM used to have their Smarter Planet initiative, we used to have that 12 years ago, it was a visionary thing where, you know, we were going to live in this interconnected world. We're going to have this intelligent devices everywhere. And we've seen that world over the last decade become real. Where there's a real promise to have the ability to make decisions in real time, and you have all of these mobile and intelligent sensors, et cetera. And what you see is today is you see these little silos of innovation and pockets of innovation across the spectrum. And what the real challenge is how do I bring these things together such that I can make more intelligent business decisions? And, you know, if you look at it from a meteorology standpoint, a perfect storm is when three or more forces come together with unusual force and magnitude. And that's really what's happening here with big data, IoT, and cloud. Is those are three market dynamics that are really coming together in an interesting way that provides the ability for you to, if you can figure out from an architecture standpoint how to handle the scale, how to handle the speed, how to handle the getting insight. You're going to have 75 billion connected devices by 2020. That's a conservative estimate. 40 zettabytes of data by then. 60% of the data loses its value in milliseconds. 90% of the data that's being gathered here is never used. So you have all of this expansion, but then with that expansion, you also have all of these security concerns, privacy concerns. How do I handle getting insight? Because it's really not the data that's important, it's the insight from the data. And if you don't do this equation correctly, then you end up with what I call you multiplying things needlessly. You're either multiplying the devices, multiplying the data, multiplying the geographic distribution, but you have no real architectural model to handle that scale. And the economic impact of these solutions, as you see, is $3.6 trillion, and that's a very conservative estimate by 2020. So let's start with some basic approaches in terms of how we're going to do this. And so when you really, many times the mistakes that people make is when they say, okay, I'm gonna build an IoT solution, or I'm going to build a big data solution, or I'm going to start using cloud. They focus on the what, or they focus on the how, and they really don't understand the why. You want to understand what is the real motivation, what is the value proposition, what are you trying to achieve, and then have that be your center of gravity, and then you figure out, okay, I understand now why I want to do this. Now I need to understand how and what I need to do to accomplish that. And then the other problem that people are doing is that they over-engineer everything. I love this chart here that, this problem is just all over the place across different industries in large and medium and small accounts where people are over-engineering things too quickly. So the key is you want to make something consumable, you want to make something a new service, you want to make it easy to understand, and you basically want to understand how new users are using that service, and then follow the feedback loop from those users to understand, okay, which direction you need to go next. So I like this chart because basically you can do everything with duct tape or WD-40, and so it's a funny chart, but it's a true chart. You don't want to over-engineer. Start small. Do what you know you can do and should do, and then you reiterate from there. And the other problem that people have is people talk about minimum viable product, but they don't understand really what that means. On the top diagram here, you'll see that, minimum viable product, you got, one wheel, then two wheels, then the chassis, then the whole car. That's not, the way you keep your consumers of your service happy. They're not happy to the end result. And in fact, because they're so unhappy during the intermediate stages, they probably will go elsewhere. Versus the bottom model where you're moving for something that's useful. It's a very simple service, but it's useful for a certain period, certain length of travel, a certain amount of task, a certain audience, and then you move up. This is the model that Apple made famous with the whole transition from, iPod to iPhone to iPad, as an example. And what you see is you see companies, the most successful companies, they also are crowdsourcing data and crowdsourcing value. So if you look at like Uber as an example, they basically offloaded all of the capital expense, the thing that held them back from an explosive growth standpoint by basically offloading that to individual users drivers that will come and bring their vehicle. And so you see that with Airbnb, Alibaba, Netflix, Twitter, where the content is better and the services are better because people are contributing value into the data set, and that you don't have to have the burden of expansion being your expense all on your own. And so I'd like to talk a little bit about the Weather Underground. You might be aware that last year IBM bought the Weather Company, and the Weather Company uses the Weather Underground to crowdsource data. So weather geeks around the world, hobbyists, will buy weather kits and donate, and basically give us access to the weather that those weather kits are collecting in that particular location. And so it's given us the ability from our cognitive models around the weather to give us a much more dense coverage across the globe. It also gave us more real-time information than we would have been able to do if we'd had to justify the expense of building our own weather stations and deploying them and keeping them up to date from a service standpoint, et cetera, et cetera. So this is the model that you're going to see, the successful companies being able to predict the future to get better outcomes because they can discover information. Some of the information is the information that they have that they own, and then they also can tap into other information. They can crowdsource information, and then to be able to predict from that and then be able to act upon it. And then you see what's happening here is you look at kind of the traditional processing. You have a high degree of analytics complexity, and you have a lot of traditional processing, human decision making. And then typically, if you can do that kind of deep data science analytics and get value out of the data that you've collected, then you can pretty much, make some decisions based off of that. But it's very elongated from a time standpoint. It's very intense in terms of a complexity standpoint, and it's very subjective because what ends up happening is when you have to move the data all to a centralized location in order to have a data scientist do a deep inspection of that data with analytic tools that are built for just inspecting things that are co-located, data warehouses, data lakes, et cetera. You run into numerous problems that cause that kind of delay in the complexity. Many times you're not going to be able to move the data because the data is owned by someone else. If you have to figure out what the terms and conditions are when you can get access to the data and when you can move the data. You also have geographic restrictions in terms of the movement of data, et cetera. So what people end up doing is they take summations of the data, extrapolations of the data, snapshots of the data, and so what that does is that causes them to have blind spots. It causes them to have extreme subjectivity included into the data set because you don't have a full picture of what's going on. And then what we see happening is people moving where they've got to make the decision much more quickly. As I stated before, 60% of all data loses its value in milliseconds. So you can't do this centralized consolidation and have only a few data scientists that have the ability to understand what the data is really saying. You need to move more towards a streaming analytics model, and then the upper right is where you automate those decisions through utilizing cognitive decision-making and artificial intelligence. And so that's the direction that we have to go just because of the volume and the complexity here. And so I mentioned earlier around the acquisition that we made about the weather company. I want to really highlight one of the major use cases that the weather company had before they became an IBM company, because it really illustrates what I'm talking about in terms of you need to get rid of the subjectivity into the data, out of the data set. So the weather company had a very tight relationship with the airlines, and so they had already provided, real-time weather type insight to the pilots, et cetera. But what they wanted to do was they wanted to put turbulence sensors onto the plane and couple the turbulence sensors and the weather data together so they could give more insight around whether pilots should fly through the turbulence or whether the planes behind the initial plane should fly through the turbulence or around the turbulence. And the first inclination when they had the discussions with the airline company was, oh, we don't need this because we have the best pilots in the business, right? But what they were basing that on, they were basing off the subjectivity of the pilots. And so what the weather company did was says, well, we'll put 20 weather sensors on your plane. We won't charge you for the insight for the data around the turbulence for the first year, but what we want to do is we want to track this for the first year, and we'll tell you what you would have saved if you would have listened to the data instead of your pilots. And what ended up happening at the end of the first year was they understood that a pilot that had a military background was consistently underestimating turbulence on the turbulence scale. A pilot from a civilian background was consistently overestimating turbulence on the turbulence scale. And that meant that subjectivity from the experience of the pilot, all right, skewed the decision about whether turbulence was bad enough such that you needed to route planes behind the initial plane around that turbulence, or whether it was okay to put the planes through that. When you think through that, that's a significant impact. You have the fuel cost if you are routing around planes unnecessarily. If you put planes through the maintenance, through the turbulence that shouldn't, then you have additional maintenance that you have to do, and there's additional risk with both of those things. And so at the end result, they found that they could have saved 50% in terms of reduction in the maintenance downtimes by listening to the data instead of listening to their pilots. And so we also have a lot of work going on in medicine. If you look at medicine, you know, if any of you on the phone, and probably all of you have, you know, had some kind of medical issue, whether it's minor or major, you know that, you know, based off your symptoms and based off of, you know, questions and tests and stuff, the doctor is making, he or she, the best estimate of what the problem is in the diagnosis, and many times it's a guessing game. You try different medications. So if you can get to a point where you know, it's not just the subjectivity and the experience of the doctor, but the doctor is adding that subjectivity and experience based off of better data. So case in point, you know, if you ask my wife, who is a double organ transplant recipient, if she had a migraine headache and you asked her, you know, scale of 1 to 10, what's your pain, she probably would rate it lower on that pain scale than somebody that's been healthy all their life and never had any pain or anything like that. So this scale of, you know, 1 to 10 in terms of pain is very subjective, and that could tilt, you know, what the physician does to try to address that particular problem. So the idea is that can we use cognitive data, cognitive analysis to get more data from more places and understand how we can make a bigger impact. So it's a very interesting dynamic. I had a customer in the healthcare space. I went on site, we had a conversation, and basically he said, he was the CIO of their operations, he basically said, I appreciate you coming from the cloud division, but we'll never use a cloud platform. We do everything in our own data center, right? And then a couple of months passed, I got called back in and talked to him, and he says, well, I'm out of data center capacity. I need to do some things on the cloud. I said, well, what happened? He says, well, the doctors, the clinical researchers wanted to take one more line of family history, and that equated to 10 petabytes of data a month, and my current data center couldn't handle it. I'm going to have to build another data center, and until I do, I want to take non-essential things and move it to the cloud, all right? And then about 3 months later, he comes back in and he said, I'm moving everything to the public cloud. And I was like, well, what happened now? He says, those darn soap dispensers. I'm like, what are you talking about? He says, well, there's these intelligent soap dispensers that basically count the number of doctors that are in a surgical, you know, an operating room, and in the number of people in the operating room is different than the people, the count of the people that scrubbed in on the way in, the alarm goes off, and it's saving us a fortune in terms of, you know, medical lawsuits and stuff where people claim somebody, you know, didn't scrub properly, et cetera. He says, do you have any idea the amount of data that sends, right? And so this is the kind of world that we're going to live in. You have to change your architectural model because you're not going to be able, once you get to this cognitive approach where you're making decisions in real time, which have more value than if you had the delay with the existing model where you centralize everything, you're going to want to have more data points. So you're going to want more, which is going to stress the system, the existing architecture even more. So the current model is very much a centrally controlled and delivered model. And the next-gen model that I'm talking about is really a peer-to-peer and decentralized, where you have intelligence, you have compute and analytics potential in devices that are out and available out there in the world and many times geographically dispersed. And so our world is more mobile and our world is going to be more connected, so you're going to have to need to move to a service delivery model that is much more of a peer-to-peer decentralized. So I like to think of it as we live in a data center world today. We're going to be moving to a centers of data world. In other words, instead of it being a north-south type of an architectural model, which is traditional hub-and-spoke data center model, architectural model today, it's going to move to an east-west oriented architectural model where it's point-to-point and decentralized. And so when I first started doing presentations like this several years ago, you know, I would speak at these IoT conferences, and I would have what I call these IoT meetups. So the people that attended the conference, sometimes they were makers of things, intelligent devices, sometimes they were service providers around data and analytics, sometimes they were security people. It was a whole hodgepodge of different vendors and customers that came to these conferences because they saw the potential future vision, the potential, if you will, of what IoT and real-time data and real-time insight could provide. But they wanted to know more information. And so when I would talk to them about some of the things that I've already talked about in this presentation, I would also invite them to what I called a meetup. And so, you know, in 2014, I had probably 15 of these meetups worldwide, and I felt like they were therapy sessions. People would come tell me their issues and problems, and they range from, okay, I'm an owner, I have data, I've got great data from their smart sensor vendor, I got great data, but I don't know how to get the best insight from that, and I don't know who might want to pay me for my data, and I don't know how to find them. I don't know how to handle the scale. I don't know how to, you know, if I want an IoT solution, you know, which vendors do I choose? How do those vendors communicate with each other? There's a whole range of issues and problems. And when the smoke cleared for me, you know, in terms of those conversations, I went back to my Advanced Innovation and Emerging Tech team, and I basically said, these are the requirements that I want you to address. I want you to be able to handle the scale by going to a peer-to-peer decentralized architectural model. I want you to be able to handle the ability for potential owners of data to find potential consumers of data and figure out how they can do things in a point-to-point monetization type of an approach. And so we created a platform which we originally called Mountain. It abbreviated Multiplying Things Needlessly because that's what people were doing. And it eventually became Blue Horizon. It was at one of these IoT meetups that I actually met the weather company, and they were working on a project very similar to what we were doing, and so we joined forces. And so the Blue Horizon became an open experiment. And first experiment that we did was with the weather company, with the Weather Underground. Another open experiment we did was with my alma mater, Clemson University, Go Tigers, the International Transportation Center, which is near Clemson. It was built at the same time and established at the same time that the largest BMW plant in North America was built there in South Carolina, 20 miles from the university. So there was a tight relationship between BMW and Clemson, and they jointly created this International Transportation Innovation Center. Well, what they're focused on is the autonomous driving, autonomous vehicles. And if you think about artificial intelligence, and we had a lot of research projects we called one Watson on Wheels. We were also working with a local motors around a company about building an autonomous driving car. You know, there's a lot of future promise around autonomous vehicles, and you already see some autonomous services showing up on the existing vehicles we have. And so all that testing, all that collaboration within the automotive ecosystem, much of it is happening at the ITIC. And it turns out that, you know, we had the seaside community in Florida. That's the area of the Gulf Coast that was devastated by the BP oil spill. They got significant funds from the BP settlement to go and revitalize that beach area. And one of the things they wanted to do with kind of building the seaside community of the future was address their travel and transportation issues. And so they wanted to leverage, you know, autonomous driving and such. So they actually reached out to the ITIC to do a project, and they quickly discovered that, okay, if I'm really going to create a smarter city, a cognitive city, I don't just want to address the transportation, I want to address the experience of the vacationer. So a lot of the work we were doing around smarter venues made sense there too. So this is a very large project that we're currently working on, and the goal is to make this, the seaside community, kind of the first cognitive city, and it become a blueprint for other cognitive cities. And we took the Obama administration, U.S. Transportation Secretary Anthony Fox through this, and we're working with folks like US Ignite and others to try to, do this blueprint around a cognitive city, cognitive services, having the ability for the vacationers to add value, crowdsource data, like I said before, be able to get the services quickly and easily. So hopefully what you'll see in the coming months is more and more information about, what it truly means to be a cognitive city. I talked about the weather, the personal weather stations with the Weather Underground. We did quite a bit of work with the weather company before the acquisition and after. But what's interesting is that once we acquired the weather company, we took a look at how we could build industry vertical solutions utilizing insights around the weather. And one such vertical we were focused on was a smarter agriculture, smarter water usage in particular in that context. And that gained visibility at the University of Kenya. We do a lot of work with this open experiment that we call Blue Horizon with the universities. And the University of Kenya, the primary, occupation in that region is agriculture. And one of their biggest problems is water utilization, when to irrigate, when to not, et cetera. And so being able to have the ability to create smarter an agricultural solution based off the weather insights and gather more weather through utilizing the Weather Underground was particularly appealing to them. We also had what we call our Purple Air project, where we were looking at smarter air. So all of these sensors throughout the city and being able to gather environmental information and then making real-time decisions of how to make things better. And so that's the real key for the cognitive, is that you want to be able to take action once you get clarity in terms of the insight. And so this actually caught the attention of the University of Shanghai. If any of you have ever been to Shanghai, you'll know that they have a serious problem as it relates to air quality. One of the things that we found is the universities, the students and the faculty are very passionate about certain topics. So like in the case of Clemson, it was because of the geographic location of the International Transportation Innovation Center and how many of their students actually go and work for folks like BMW. Sometimes it's something that's passionate, that the students are passionate about, making their city better, making their country better, improving environmentals, improving the lives of their family members, et cetera. And so that's why you see a lot of the universities that have gravitated towards this open experiment. We also, with the NYU, the CityGram project was around noise. The students wanted to really focus on, how do you use cognitive analytics to optimize and reduce the noise? Could you take actions? And part of this is figuring out, okay, what are the sources of noise and what kind of adaptations could you potentially change to make that problem better? So that's another project that we did. We also, in terms of security, when you look at, you probably saw in the press last month that there was a very large denial of service attack on the Internet. They attacked Devine, which is a company that's now been acquired by Oracle recently, but it's focused on providing the DNS services. And basically the attack wasn't from individuals. It was indirectly from individuals, but the attack came in from devices, smarter devices that basically had been programmed by individuals to go start doing, unusual things. And so it was a denial of service attack, not from one location, but very geographically dispersed. And it was very hard to defend against because of, they really never had to defend against that type of an attack where it was coming from smarter devices. And, when you look at the security models that exist today, they all are kind of that centralized model. It's you basically have the connectivity and the solutions, and then you kind of lay security on top. When you move to this point-to-point decentralized model, you have to get to a point where you can actually handle point-to-point security in real time. It can't be added on after the fact. It can't be a centralized security process. It needs to be baked into the transaction. And so that's why you see the technology like blockchain, which is underneath the cryptocurrencies, it's very decentralized in nature. It's very much around this point-to-point authentication, authorization, and then to basically, you know, have the ability for there to be a consensus that this is a good transaction, and then that is documented in an open ledger. And so we're doing lots of work with the Blue Horizon project and some of our researchers in IBM around our blockchain technology, around having an open ledger. We started a community called Hyperledger, and we're building solutions on top of that kind of blockchain technology. It turns out we were using blockchain and the security services around the point-to-point authentication pieces to help do some of the authentication and security services as part of our Horizon work. It turns out that we came across a group inside of MIT that was doing a project called Enigma, which was remarkably similar. So we have now kind of joined forces, if you will, with the MIT folks on that project. So I think, you know, you will see over the next couple of years some significant changes in the way security is done. The security will be baked into the transaction, and, you know, typical security today is around identifying the device, identifying the user, identifying the target application, and again, it's very north-south in its architectural model, and like I said before, it's kind of added on after the fact. And what I see is going to be very much a point-to-point, east-west, real-time model where it's baked into the transaction. And the other aspect of this is that the orientation around security is not the individual or the device as much as it is the flow of data. Who has access to the data? How is the data allowed to flow through certain, you know, users and consumers and geographies? So the orientation of security moves from the user or the device or the application to the actual data and the flow of the data thereof. And so that's what you're going to see coming across. And the other thing with security that we're focused on with this project that we're doing with MIT is to provide cognitive security. In other words, today, if you think about how denial of service attacks are found out, and the reason why the Devine attack was so hard to stop was it's all reactive, right? Signatures of the attack. Oh, well, we have to recognize this is an attack of this type, and then put some kind of, you know, firewall rule or policy or whatever in place so that it stops that attack, all right? Well, what do the hackers do? They go to another attack vector, all right? What we try to do with cognitive security is determine what normal behavior looks like, and anything that's not normal behavior therefore is considered abnormal behavior and therefore challenged. And that's kind of the aspect of changing the security dynamics to be oriented around data, and instead of it being reactive but to be proactive. I think that's going to be what you're going to see in the very near future coming to reality, and that's going to be the architectural orientation moving forward. And the companies that move to this architectural model can handle the scale. They're going to handle the ability to be very objective because they can handle the data in real time, and they're going to be able to make real-time decisions, and they're going to do this with a way that's trusted because of the security models that are going to be put in place. The companies that do that are going to thrive. The ones that don't aren't going to survive. And so with that, I'll stop and open up the line for any questions people might have.
Okay, thank you so much, Mac. We do have a few questions here, so I'm going to read them back in the order in which they came in.
Okay.
The first one is the blockchain solution, and in quotes, heavy?
Okay, so that's a great question. So if you're familiar with the blockchain technology, like I said before, it's a very decentralized technology. It's a peer-to-peer, point-to-point decentralized technology, so it has the right architectural model for the future, in my opinion. It also enables this aspect of getting rid of the middleman, if you will. So, like, one of the problems that people experience today is that if you and I want to do a collaboration together, and we're two different companies, we got to have to put the terms and conditions in place of how we're going to adhere to that, and we have to do a whole bunch of lawyers, a whole licensing agreement, and all that. With the blockchain technology, it allows us to do that kind of point-to-point interaction and create kind of smarter contracts on which we can then agree to the terms and conditions of which we're going to adhere to, and then we've written with the project that we did governors that basically monitor whether each party is adhering to the terms and conditions of the contract. And so what we found when we did this was that, you know, there's a certain level of maturity for the blockchain technology. Blockchain technology was written for cryptocurrency, point-to-point commerce, and, you know, the expectations for that type of use case were such that it had a certain scaling and performance characteristics, a certain heaviness, if you will, that is not appropriate for other use cases. And so what the Horizon project does is it uses the blockchain as an open ledger to basically document what was agreed to and document the you know, time of the transaction, the agreement, et cetera. But the actual data tier where you're doing the interactions is done on the data plane. It's not done within the blockchain itself because it would not scale, it would not perform adequately. Now, there's a whole slew of people in the blockchain community that are trying to address some of the scaling and performance issues that blockchain has for purposes that it was never designed to do. But, you know, today we believe that, you know, if you use it as an open ledger, as a way of ensuring that you can, you know, get the right terms and conditions for that type of interaction, but you utilize other point-to-point decentralized services for the data tier, then you're much better off. So case in point, a lot of the work that we did, there was an announcement about a month ago with Canonical, the distributors behind the Ubuntu distro for Linux. They came out with their core distro, which is focused on IoT. It's a scaled-down Linux operating system, and it has a snap architecture. So basically what it is a developer, instead of having to take all of the Linux kernel, which requires a big edge, if you will, you can scale that down, use their core, and you can just snap in only the services you need. And so one of the things that we found with that is it significantly improved the IoT interactions, both things with the blockchain that were directly integrated with the blockchain and things that were done at a data tier outside of the blockchain, because I reduced the overhead and only basically snapped in just the things that I needed and no more than that. And so you see the market dynamics here. You know, the traditional tools that we have are too heavy. Even some of the new technologies like blockchain in its current form are too heavy. And what you see is an optimization, a scaling down of that such that you get down to smaller and smaller devices and build more and more intelligence in those devices. So we're still fairly early days in that, but I see a lot of movement, in particular over the last 12 months, towards that scale down, optimized model and moving away from kind of the heavy, monolithic, scale-up type of architectural model.
Okay, the next question we have is, do we need a new IP to secure the networks?
All right, so like I said before, you know, in my opinion, and this is Mac's opinion, so take it as such, there are several major issues that we have to address in terms of the security architecture. As I stated before, most of the security implementations that we have today are not baked into the actual transactional fabric. They're laid on top. They are kind of after the fact. They're separate from the actual solution itself. The other problem is they're oriented around the device, the user, the application. They're not oriented around the data and the flow of data. And so those two things, in my opinion, have to be addressed. The security has to be kind of baked into the actual solution. It has to be much more of a point-to-point decentralized security architectural model. And it needs to be able to handle the orientation around the security needs to be oriented around the data and the flow of data and the access to the data more so than the device and the individuals. And then the other piece of this is that I mentioned before is all of the security models today in terms of protecting firewalls, denial of service attacks, et cetera, are all reactive. once the attack has taken place, you discover that the attack is there, you figure out how they attacked you, and then you put something in place to stop a future attack that looks just like it. That's a bad model. If you look at, like, for example, what the Israeli military did with the Iron Dome, if you're familiar with the Iron Dome defense system, what they did was they did deep learning and analytics to understand what the potential threat matrices were, and anything that was not considered normal, all right, so they learned what normal behavior was. Anything that was not considered normal was considered a potential threat. That's the kind of model that we're talking about here, and that's what we're doing with our cognitive security, is things like we use deep learning, get to the point where you can get cognitive insight, take the subjectivity out, and instead of trying to recognize what bad behavior looks like, understand what good behavior looks like, and anything that's not recognizable as good behavior is therefore bad behavior. I think that's the orientation we're going to see different. I think you're going to see a tremendous amount of innovation in this space. There's lots of VC money pouring into startups to change that orientation, including the Israeli market, like I mentioned before, where they're taking some of the cognitive security capabilities that grew up kind of in the Israeli military, and now there's actually some startups that are using that same kind of technology. So I think that's the kind of thing you're going to see, and you're going to see more and more of it over time.
Okay, so next question starts out with, thank you for your presentation. It was very interesting. I would summarize your SurThrival model, at least in part, as connecting lots of data with compute to drive cognitive computing. Hopefully I'm not mischaracterizing that. Can you say more about how you deal with the challenge of getting the data to compute or the compute to the data?
Yeah, so that's the whole crux of what we did the Horizon Project for, because that was the problem that you had. You couldn't get the data to the compute, and you couldn't figure out how to leverage the compute that was near the data, all right? And so how do you discover that there's compute at the edges that you could light up that's near the data that you could use? And how do you get to a point where you can actually get the data to where you needed to be from a centralized model? And so that's why we went to this decentralized autonomous compute model, where you could discover edges and basically create smarter contracts between the back-end systems and that edge, so that you could allow access to the data. You could also allow access to the compute there at the edge. So then, instead of trying to bring the data to a centralized place and creating cognitive models there, you could actually create cognitive models at the edge where the data is, where the streaming data is coming in, and then you could basically take summations and insight that you gather from the edge and pull that back into the back-end systems. So you're not sending the raw data, you're sending the insight, the intelligence to the back-end systems, and so you're gathering up that aggregation of insight across all your edges, and then you're redefining your models, and then you're pushing the new model out to the edge. So this aspect of being able to, I mean, there's more compute power in a mobile phone than what NASA had to send a man to the moon back in the 60s, okay? When you look at things like I talked about with Canonical, with their Ubuntu Core and their Snap architecture, there's going to be more compute capabilities, more capabilities in general that are available on smaller and smaller devices. And so how do you take advantage of that excess compute? And so this aspect of being able to say, instead of moving, this is why I said we're moving from the data center model to the centers of data model. Instead of trying to move things to a data center so I can have a centralized compute and centralized analytics kind of model, I have this aspect of a cognitive edge or cognitive edges and a cognitive cloud, and the edges become more intelligence over time because I'm getting more intelligent at the aggregation layer at the cloud, and I'm redefining the models and pushing those models out to the edge. That's exactly what the weather company did with their architectural model, and that's why today when you look at, like, if you're a fan of baseball like I am, you might remember that they actually 28 hours in advance moved the time of the World Series game between the Cubs and the Indians because they knew it was going to rain in Cleveland at 11 p.m. the next day. And sure enough, exactly 11 p.m. the next day. That's because of the cognitive modeling that the weather company did, and they did it at the edge, and the edge becomes more intelligent, the cloud and all the models become more intelligent, you're pushing that out. So it's still fairly early days, but you will see a tremendous move towards that decentralized autonomous model, and you see companies, big and small, coming out with more and more technology in that space, and I see no end in sight, because that's the only model that really can scale and that you can really provide the insight at the speed at which you need it. So.
Okay. Our next question, the person asking the question is guessing that you have some familiarity with NOAA's Big Data project, which IBM is one of the initial partners in that project. And assuming that you do, can you describe a bit how that fits into what you talked about today?
Yeah, so you know, when you look at big data project like the NOAA project as an example, is that you could, with the architectural model that the weather company had as an example, we learn to scale and get insight in as real-time manner and at the scale at which we could handle with kind of a hybrid kind of architecture, because they didn't do everything centralized, but they didn't do everything in a completely decentralized fashion. And so, you know, it was the largest, the weather company when we acquired, was the largest production IoT solution in the world. Weather is the largest data set in the world. And we're using projects like the one with NOAA to basically define and improve our cognitive models, and we're learning from that. And that's one of the projects that, you know, of many projects like that where, you know, we're trying to learn how to make better and better models and be able to react to changes more quickly and being able to deploy those in new and interesting ways. And so that's one of the projects that we have adapted since the weather company acquisition. We're doing much more on that project. We always had our IBM research teams kind of working with those kinds of agencies, but now, you know, with the weather company and having weather insights across all 12 industry verticals that IBM focuses on, those projects are now, you know, even further embraced by IBM. And so we're quite active in working with a variety of different government agencies and international agencies on data sourcing, crowdsourcing, you know, data cleansing, model definement, et cetera. So, you know, once you kind of get down this path towards doing things in a cognitive AI way, you realize quickly that it's a significant competitive advantage versus doing it the traditional way where you have all the subjectivity factored into the typical way you tried to collect data. So.
Okay, another question here, you may have touched on this a bit, but the question is, a lot of the time we spend on data is on the low-level stuff, cleaning, organizing, formatting, adding metadata, et cetera, et cetera. This is time-intensive. Are there emerging solutions?
Yeah, so what you just described was a typical way we have to do this for a centralized data repository model, because, you know, if you're going to the trouble to moving the data to a centralized place, you want to make it sure that it's organized and as clean as possible so you can get the best insight possible, right? And those kind of things will still continue, but they need to be supplemented. You need to extend beyond that type of a model to a real-time streaming analytics model, a cognitive AI model, where I don't spend that time trying to organize the data or cleanse the data. I spend the effort on trying to understand what the data is saying and understanding that in real time. And you see a number of technologies in the data analytics space emerging, making that transition. So there's a lot of streaming analytics products. There's a lot of move towards a Spark model. That's why you see an explosion on the cloud side into non-relational databases, because, you know, the time, the intensity, the skill required to kind of do the traditional relational database typical data mart, data warehouse, data lake kind of model. And that goes back to the earlier chart that I had where I showed the kind of traditional processing, traditional way of doing, advanced analytics is complex and it's time-consuming. A large part of that was for the reasons that the questioner gave, and we're moving more towards a streaming analytics cognitive model where you may, have more quote, unpolished data, if you will, but you have more collection points and more points of reference so that you can actually combine that with other insight, and therefore you can get to an answer that's actually better and quicker than you would if you would spend all that time organizing and cleansing and such. So I think you'll see a transition more towards the model where you do less of those kinds of tasks. You only do that for the things that are kind of a long duration and important enough to justify those tasks, and then the other more real-time analytics, insight, and time priority projects being done in the other architectural model.
Okay, are there any more questions at this time? If there are, get typing really quickly. Your time is running out. And if not, we're going to wrap up today's webinar. Max, thank you for a very enlightening, very interesting presentation. We greatly appreciate your time.
And like I said, that first part had my contact information on both Twitter and email, so if folks do have questions they think of later or they want to have more information about some of the architectural changes and some of the things I talked about, feel free to drop me a line either by way of a direct message on Twitter or an email. Either one's fine.
That's right. And Mac's presentation will be on the website, at the NCDS website later this week, and so you can get all that information there too. Thanks to the audience for taking the time out of your busy day to attend DataBytes. This is our last webinar of 2016. We'll be back again with more talks on hot data topics next year. Our first webinar is scheduled for Wednesday, February 1st, 2017. So look for more information about upcoming DataBytes webinars on our website, which is datascienceconsortium.org. You can also sign up for our newsletter and updates on the website. Mac, thanks once again. Everybody take care, have a safe and happy holiday season, and we will be back in touch with you next year.